Okay, 2018 APAB number 5. This is another really good question they could use this year because they are testing a lot of concepts in this one question. So we have f of x is e to the x times cosine of x. Find average rate of change on the interval. Okay, average rate of change, f of b minus f of a over b minus a. So f of pi minus f of 0 over pi minus 0. So e to the pi cosine of pi minus e to the 0 cosine of 0 over pi minus 0. E to the pi stays pi, cosine of 180 is negative 1, minus e to the 0 is 1, cosine of 0 is 1, so minus 1 times 1 over pi. Gives us negative e to the pi minus 1 over pi. That's our average rate of change on that interval. Part B, slope of the line tangent to the graph at 3 pi over 2. So we need f prime. So f prime of x, product rule. First times the derivative of the second. So e to the x times derivative of cosine, which is negative sine x, plus the derivative of the first. Derivative of e to the x is e to the x times cosine x. And now we sub in our 3 pi over 2's. So e to the 3 pi over 2 times negative sine of 3 pi over 2. Sine of 3 pi over 2 is sine of 270. Sine of 270 is negative 1. So it's e to the 3 pi over 2 times 1 plus e to the 3 pi over 2 times the cosine of 3 pi over 2. Cosine of 3 pi over 2 is cosine of 270, which is 0. So that goes away. So our answer to part B is just e to the 3 pi over 2. Part C, find the absolute minimum value of f on the interval from 0 to 2 pi. Justify your answer. So here we go again. Absolute minimums. To find an absolute minimum value, first of all, we take into account our endpoints. So we have to, evaluate at 0 and 2 pi. But then we also have to worry about where is our first derivative equal to 0. We have to take into account the relative extrema. So we set e to the x cosine x minus sine x. I just rewrote what I had up there. I factored out an e to the x. So when is cosine x minus sine x equal to 0? Or when is cosine x equal to sine x? That's at 45 or pi over 4, or again in the third quadrant at 5 pi over 4. So those are our critical values that we have to test and see what the value of our function is. And we are looking for the absolute minimum. Okay, so at 0, e to the 0 times the cosine of 0. Remember, we're evaluating the function, e to the x cos x. So e to the 0 is 1, cosine of 0 is 1, 1 times 1 is 1. At pi over 4, we have e to the pi over 4 times the cosine of pi over 4. So that's e to the pi over 4 times rad 2 over 2. Can't do too much with that. At 5 pi over 4, e to the 5 pi over 4 times cosine of 5 pi over 4. So that's e to the 5 pi over 4 times negative rad 2 over 2, because now we're in the third quadrant, cosine's negative. And then finally at 2 pi, e to the 2 pi times cosine of 2 pi is not 1, I don't know what I wrote there, is e to the 2 pi. All right, cosine of 2 pi is 1 times e to the 2 pi is e to the 2 pi. But we're looking for the minimum, so the minimum is the negative 1. So it wants to know, find the absolute minimum value. There it is, negative e to the 5 pi over 4 times rad 2 over 2. Okay, the last part. Let g be differentiable functions such that g of pi over 2 equals 0. The graph of g prime is shown. Find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Justify your answer. So we start off and we say, okay, it's a limit. So let's evaluate f of pi over 2 over g of pi over 2. F of pi over 2 is e to the pi over 2 cosine pi over 2. Cosine pi over 2 is 0. And they told us in the question that g of pi over 2 equals 0. So we have 0 over 0. So when we have 0 over 0, we're gonna have to use L'Hopital's rule. So the limit as x approaches pi over 2 of f of x over g of x is the limit as x approaches pi over 2 of f prime of x over g prime of x. And we do our two limits separately. Limit as x approaches pi over 2 of f prime of x is e to the pi over 2 times the cosine of pi over 2 minus the sine of pi over 2, which becomes e to the pi over 2 times 0 minus 1. So it's negative e to the pi over 2. G prime of x, limit as x approaches pi over 2 with g prime of x. Well, we look at our graph up there, and we see the limit from the left and the limit from the right as x approaches pi over 2 is 2. So now using L'Hopital's limit as x approaches pi over 2 of f of x over g of x is negative e to the pi over 2 over 2. So again, really good question, a lot of good concepts in here. AROC, slope of the tangent line, so derivatives using a product rule, trig, E, absolute minimum. Again, big concept. You have to compare your endpoints to the critical points on the interval, and then using L'Hopital's rule. So this is another good one.